This video is on creating equations, so these could be called applications, they can be called word problems, but we need to turn them into equations and then find the solutions. So let's start right off with this example. Gwen deposited $600 into her bank account. Her account balance is now $4,631. How much money did Gwen have in the account before making the deposit? All right, $600 went in, so she's increasing her balance. It's now $4,631. Let's let X equal the original account balance. The balance is the amount of money in a bank account. So X is the original balance. So let's trace through this. So at the beginning of time here in this problem, Gwen has X amount of money in the bank. She made a deposit. A deposit increases your balance. She deposited 600, so we're adding 600 to X, and the balance is now 4,631. So we've created a one-step linear equation. We know there is one rule. We need to get X by itself. So we're going to subtract 600 to from both sides. Why? Because 600 minus 600 is 0. X is by itself. And 4,631 minus 600 is $4,031. So the original balance in the account was $4,031. Now, some of these problems you can just solve by inspection, by thinking about what actually happens. Our goal, however, is to learn how to translate words into math, so that when the problems are too hard to solve by inspection, we have the skills we need. All right, this next example is very basic. The reason I'm including this example is because of this phrase right here, less than. Okay, so less than. It says 12 less than a number is 10. Find the number. I'm going to let X equal the number. Now, less definitely means subtract, because something is smaller than something else. Less than means you have the number and you're taking away the 12. So you want to be really careful when you see a less than to write the phrase sort of in backwards order. So it's not 12 minus X, it's X minus 12. So that less than phrase, you need to think of it as sort of turning the subtraction and the 12 around. Is translates as equals. So if we take 12 away from a number, we get 10 for the answer. We again have a one-step linear equation. We're going to add 12 to both sides. Why? Because negative 12 plus 12 is 0. That leaves X by itself, and 10 plus 12 is 22. So the number is 22. All right, let me put my answers in little bubbles, little clouds. The next problem says 8 more than a number. So here's this phrase, more than, so something's bigger than something else. More than tells us to add. So we're going to let X equal the number again. And this time we want X to be increased by 8. 8 more than the number is 23. This is a one-step linear equation. I'm going to draw a line at the equals. I need to get X by itself, so I'm subtracting 8 from both sides. 8 minus 8 is 0. X is by itself. equals 23 minus 8 is 15. So the number is 15. Next problem says Logan withdrew $26. When you withdraw money from your bank account, you're making the balance in the bank account go down. So you're basically going to the ATM and you're pulling out 26 bucks. After the withdrawal, his balance is $123. How much was originally in his account? So we're going to let X equal the original amount. What did he do to the original amount? Well, he withdrew, he took away $26. And now his balance is $123. We have a one-step linear equation. Our goal is to isolate X. So we need to zero out the 26. So negative 26 plus 26 is 0. Leaving X by itself. 123 plus 26 is 149. So originally he had $149 in his bank account. Okay. Next. After taxes, Luis's take-home pay is 8/10 of his salary. So if you divide his salary into 10 parts, he gets 8 of them. And the government gets 2 of them. 8/10, that's his take-home pay. If the amount of his actual take-home pay is $672, what is his gross pay? Gross pay is another way to say his salary. Okay, so I'm going to let X equal gross pay, or you could say let X equal salary. Now, 8/10 of his salary, 8/10 of his salary, that's a portion of his money. And when you see that fraction of something, that's an indication that you need to multiply that fraction by whatever's next. 8/10 of his salary is the same as 8/10 of his gross pay. So his take-home pay is 8/10 times X. We also know that his take-home pay actually is $672. So 8/10 of his salary is equal to $672. All right, now we're going to go ahead and solve this equation. Now, since you're probably using a calculator, we can solve this by simply dividing both sides by 8/10. Now, why do we divide? 8/10 is being multiplied by X. And 8/10 divided by 8/10 makes a 1. And when you have 1x, that's the same as having x by itself. Now, of course, that one rule of solving says if I divide the left side by 8/10, I also have to divide the right side by 8/10. When you divide $672 by 8/10, you get $840. So his gross pay is $840. That's before they took out the taxes. So that's the solution of the equation. All right, the next example is demonstrating the use of the word quotient. Quotient means fraction, basically. The quotient is the answer to a division problem, and a division problem can be symbolized with a fraction. So we're going to let x equal the number, because that's what it tells us to find. What is the number? X is the number. The quotient of the number and 3. That means build a fraction out of x and 3. So x over 3. Is means equals. So we know that x over 3 is equal to 12. Now we want x by itself. Currently x is being, currently x is being divided by 3. We need x by itself. So I need the 3 to cancel. So what I do is I put a 3 in the numerator with the x, because 3 divided by 3 makes a 1. Now if I multiply the left side by 3, I have to multiply the right side by 3. And I get x equals 12 times 3, which is 36. So the number is 36. The next problem says an 8-ounce cup of coffee contains 184 milligrams of caffeine. This is 5 times this. This refers to the previous statement, which is caffeine. This 184 milligrams of caffeine is 5 times the amount of caffeine in a 12-ounce soda. How many milligrams of caffeine are in a 12-ounce soda? So we're going to let x equal the mg's of caffeine in the soda, the 12-ounce soda. Now let's go back and start translating. An 8-ounce cup of coffee contains 184 milligrams of caffeine. This, the 184 milligrams of caffeine, is, remember that word is, tells you where to put your equals. 184 is 5 times the amount of caffeine in a soda, which is given by x. There's our equation. This is a one-step linear equation. Our goal is to get x by itself. Currently, x is being multiplied by 5. So I divide by 5 because 5 divided by 5 makes 1. Now if I do it to one side, I have to do it to the other. 184 divided by 5 is 36.8. So a 12-ounce can of soda contains 36.8 milligrams of caffeine. Next problem. Annabelle wants to buy a $270 bike. She has already saved $110 and will save $15 each week until she has enough. How many weeks will it take Annabelle to reach her goal? All right, so we're looking for the number of weeks it will take her. So we're going to let x equal the number of weeks. Now, her goal is $270. She already has $110, and she's adding $15 each week until she has enough. Now, she can't just add $15 once, because then she'll only have $125. She has to add $15 several times in order to have enough money. So it's $15 times the number of weeks, and she stops when she gets the $270. So the equation 270 equals 110 plus 15x is what we need to solve. We're going to move the 110 first by subtracting it, because 110 minus 110 is 0. That leaves 15x on the right, and it leaves 160 on the left. Now the 15 is being multiplied by the x, so we divide by 15 because 15 divided by 15 is 1. We also have to divide the left side by 15. And 160 divided by 15 is, I'm using my calculator, 160 divided by 15 is 10 10.6 repeating. Okay, I'm going to write that down. 10.6 repeating equals X. Question, is she going to have enough money after 10 weeks? 10.6 repeating is almost 11 weeks. So Annabelle needs to save for 11 weeks before she has enough. She needs that last $15 to push her over the top to get her $270. Notice I rounded up. All right. Evelyn's, Emma's, and Ethan's ages are consecutive integers. Let me underline that. Consecutive integers. The word consecutive means coming one after another. Integers are just numbers we count with, basically. Evelyn is the oldest and Ethan is the youngest. The sum of their ages is 45. How old is each person? All right, well, we need to let X equal one of the person's ages. So I'm going to go with Ethan because he's the youngest. So I'm going to let X equal Ethan's age. Now, consecutive integers are things like 4, 5, and 6, or 10, 11, and 12. So if X represents Ethan's age, then the middle child, which appears to be Emma, is X plus 1. So X plus 1 equals Emma's age. And Evelyn is the oldest. She is 2 years older than Ethan. So X plus 2 is Ethan's age. Now the word sum means add or total. So we're going to take Ethan's age, we're going to add it to Emma's age, and then we're going to add that to to Evelyn's age in order to get the sum total of 45. Now, I wrote Ethan's age, so let me fix that here. This should say Evelyn's age. All right, now in each of these parentheses is preceded by the number 1. So basically the parentheses aren't necessary, so I'm just going to drop them. X plus X plus X is 3X, and 1 plus 2 is 3, and that's equal to 45. This is a classic two-step equation. I'm going to zero out the 3 by subtracting it from both sides. You get 3x equals 42. I'm going to divide both sides by 3 because 3 divided by 3 makes 1. And I get x equals 14. So remember, X was Ethan. Ethan's 14. The kids' ages are consecutive, so Emma must be 15, and Evelyn must be 16. So their ages are 14, 15, and 16. Next problem. The purpose of this problem is to introduce you to this phrase decreased by, and the word times, which you know from elementary school. 15 decreased by 2 times a number is 3. So 15 is the star here. We're looking for the number, okay? 15 is our starting amount. It's decreased by 2 times a number. So it's 15 minus 2 times x, or 15 minus 2x. Remember, is means equals 3. 15 minus 2x equals 3. This is a two-step equation. I'm going to zero out the 15 first. 15 minus 15 is 0. Recopy the negative 2x equals 3 minus 15 is negative 12. I need to make a 1 in front of the x, so I divide both sides by negative 2 because negative 2 divided by negative 2 is 1. X equals negative 12 divided by negative 2 is positive 6. So the original number here was 6. A car rental agency charges a $35 rental fee, $20 for gas, and 15 cents per mile. You have $72. How many miles can you afford to drive this rental car? So X is going to be what we're looking for, which is number of miles. Now let's take a look at the facts here. They charge a $35 rental fee. They also charge $20 for gas, and then they charge 15 cents per mile. So they don't just charge the 15 cents one time. They charge 15 cents for every single mile you drive the car. So they're going to check the odometer before you leave, and then they're going to check the odometer when you get back. And they're going to charge you for the miles that you've driven. So the 15 cents, 0.15, needs to be multiplied by the number of miles you drive the car. These three costs have to add up to 72 or less because that's all the money you have. All right, well, I see some simplification. So before I start solving, I'm going to combine my like terms. 35 plus 20 is 55. Plus 0.15x equals 72. Now I'm going to start solving. I'm going to take away the 55 from the left, which leaves me with 0.15x alone on the left. 72 minus 55 is 17. Yes, of course. And then I need to isolate x. The 0.15 is being multiplied by x, so I need to divide by it so that that coefficient on x reduces to 1. That leaves me x equal 17 divided by 0.15 is 113.3 repeating miles. Okay, that's not a super practical answer, so we would say that you can drive the car 113 miles. All right, we've got one more problem. This one's pretty crazy sounding. Rob had twice as much money as Sam. Then Sam gave Rob 1 quarter, 2 nickels, and 3 pennies. Rob gave Sam 8 dimes. They now have the same amount of money. How much money did Rob have originally? All right, so let's write down. Let x equal Rob's money, the original amount that Rob had. We know that Rob had twice as much money. You know what? I changed my mind. Because Rob has twice as much money as Sam, we want to let x equal the smaller amount. It just makes the math a little easier. So we're going to let x equal Sam's money. Then we can translate Rob had twice as much. The word twice means 2 times. So 2 times x equals Rob's money. Now let's trace through the actual timeline of events here. Sam gave away some money. He gave away 1 quarter So that's one 25-cent piece. He gave away 2 nickels, so that's 2 times 0.05. And he gave away 3 pennies, which are worth 0.01. Rob, so this is what Sam did. Rob started with 2x, and he gave away 8 dimes. Dimes are worth 10 cents. They now have the same amount of money. So this blue expression and this green expression are the same. So I'm going to rewrite it. I'm going to simplify the blue expression by figuring out how much money Sam gave away. Let's see, 25 cents. 2 nickels is 10 cents. And 3 pennies is 3 cents. So Sam gave away a total of 38 cents. So x minus 0.38 equals Rob started with 2x and he gave away 80 cents, 8 dimes, so that's 0.80. I'm going to move the x on the left by subtracting it to zero it out. This crosses out, makes 0. That leaves me with negative 38.38 equals 2x minus x is x minus 0.80. And now I'm going to get x by itself by adding 0.80 to both sides. Negative 0.38 plus 0.8 is 0.42 equals x. So Sam started with x. Sam's money was x. So Sam started with 42 cents, which means Rob started with 84 cents. He started with twice as much money. This is the answer we're looking for. Rob started with 84 cents. All right, this video is on just a sort of a mixed bag of creating equations from lots of different situations. Hopefully you have picked up some hints and tips. Just always remember to be logical. Thank you for watching.